Part 2, this is for questions 7 to 10. Question 7, let f of x be equal to this. Part A, express f of x in partial fractions. So since we are having two linear factors, then we shall have this 2 out of 2x minus 1. This is 2x plus 1. This is the same as a, then out of one of the factors, 2x minus 1. And then the other one would be b, out of then the 2x plus 1. Then you just multiply this with that also using the butterfly method. So you have a times this 2x plus 1, then plus b times the 2x minus 1, and then we equate this one to the numerator, which is here. Why do we equate to the numerator? This one is out of the common denominator that we can get from here is when we multiply the two. And this gives us exactly what is here. Now you say this one here divide by the 2x minus 1. This one disappears. Then you get this one here. Not so. The same thing we do here. And we say this divide by this one. So the 2x plus 1 cancels with this. Then you get the 2x minus 1 is the one you multiply with the b. That is what you're seeing here. Okay, then as one fraction, then this one will be out of this, and it is the same that is also out of this 2 here. Now you see that the denominator is the same, so that means even the numerators are the same. So this implies that after multiplying these ones here, then you equate them to the numerator. And then our task here is to find the values of a and b. You get the values of x that you can substitute in here such that you can terminate some of the terms. For example, if x is equal to a half, when I put a half here, I'll get 1 minus 1, and then that will be a 0. So that means this one will disappear, and then I will remain with this. So a half of 2 is a 1, then plus 1, that will be 2a, which is equal to 2. So meaning a will be equal to 1 when we divide all through by 2. Now, if we equate this one to 0, we shall get x being equal to a half. I mean negative a half. So this one goes, now we go to this one here. You get negative a half times the 2, you get negative 1. Then minus 1, that will be negative 2b, which is equal to 2. So meaning b is going to be equal to negative 1 when we divide all through by negative 2. So meaning that f of x, okay, yes, f of x here is therefore going to be 1 then out of 2x minus 1 and then minus 1 out of the 2x plus 1, and that is that. Then part B, using your answer to part A, show that f of x squared is this. Now f of x squared is going to be this is our f of x here. So I will say 1 out of 2x minus 1, then minus 1 out of 2x plus 1, and then squared. So what are we going to have? Get this, you square it. Okay, you get this one here and you square. So we are going to have 1 out of 2x minus 1 squared, then this times that. Then we are going to get minus 2, then times 1 out of 2x minus 1, then 1 out of 2x plus 1, and then square this one here. So we shall get 1 over 2x plus 1, then squared. Why am I using this one? In binomial expansions, you have a plus b squared is the same as a squared plus 2ab, then plus what? B squared. That is exactly what I'm applying here. Okay, don't get lost. In fact, let me change this plus here to a minus such that we be systematic. Okay, what we are doing here is exactly what we are having here. Then of course here when you square 1 you get 1, then out of when you square what is here, this will be 2x minus 1 squared. Then this is minus, this 2 can multiply with everything here, then out of you get 2x minus 1, then times the 2x plus 1, then plus 1 out of 2x plus 1 squared. But they said use your answer to part A to show that this is that. Now, do you see this part here? That it is the one which was given here, this one, and it gave us this. So therefore, where there is this, I'm going to put this. So this implies that we shall have 1 out of 2x minus 1 squared, then minus, I'll put everything in brackets so that we don't do errors here. Minus 1, then minus 1 out of 2x plus 1, and then plus 1 out of 2x plus 1, then squared. Okay, now if we open the brackets, that means we are going to have 1 out of 2x minus 1 squared, because this one here affects this and it becomes a minus, 2x minus 1, and then a minus and a minus, that one becomes what? A plus. 1 out of 2x plus 1, then plus 1 out of 2x plus 1 squared. Isn't it what we are having up here? I think that is what we are having. So f of x squared is this one here. Part C, hence meaning begin from where you have stopped. Show that when you integrate from 1 to 2 of this f of x squared with respect to x, we get this. Okay, so when we integrate this f of x squared with respect to x, we are having, of course it is from 1 to 2, we are integrating 1 to 2, 1 over 2x. You know, this one, it was like this, then squared. So I'm going to write this as using the rules of indices, so I give it power negative 2. Then I'll also have 1, this one is 1 over. Now the integration of this one is different from this. So this is 2x here, then minus 1, then 1 over 2x here plus 1, and then plus, this one I will take it up, so 2x plus 1, then to the power of negative 2, then with respect to x. Now, we increase the power by 1, we get a negative 1. We divide by that new power, then times the derivative of what is inside here, which is a 2. And then here, when we differentiate this one here, when we differentiate the denominator, we get a 2. Are we there? But here we are having a 1. So what should we do to this 2 in order to get a 1 here? We multiply it by a half. Now, what I've done to my derivative is going to be the, what we call the coefficient of the natural log of the denominator. So what do I mean here? I'll put a half, then the natural log of the denominator, which is 2x minus 1. The same thing here, when I differentiate this, I get a 2, but how do I get a 1 here? Is by multiplying it by a half. So we shall also have a half here, then the natural log of 2x, then plus 1. And then here, increase the power by 1. We get a negative 1. Divide by that new power, but then times the derivative of what is inside here, because that one comes from the chain rule in differentiation. So that is that. Then we can put our limits. We have 2 and then a 1. Okay. Now maybe I can simplify this. I can take this one down, and this one will be a negative 1 out of 2 into this 2x minus 1. Then I can have plus a half. So a half here is common. Then we have natural log. And then from here, if we are subtracting logarithms to the same base, what do we do to the powers? We divide them. So I have factorized out this a half. Then now we have natural log of this minus natural log of this one here. So I'll have 2x here plus 1, then I'll divide by the 2x minus 1, like that. Then, of course, this one, just like I've done here, is going to be negative 1 out of, then the 2x plus 1, but it is multiplying with this 2 down there. Okay, so that is what we are having there, simplified. So 2, 1. Now let us put the limits. Let us put 2. So here we shall get negative 1. When you put 2 here, you get 4 minus 1. You get 3 times 2. You get 6. So negative 1 out of what? 6. Then what else? We come to this one here. That will be plus a half. Then put a 2 here. 4 plus 1, 5. Then 4 minus 1, 3. So natural log of 5 over 3. You see that? Then minus 1 out of, when we put 2 here, this one becomes a 4. Plus 1, 5. Times 2, 10. So 1 out of 10, like that. Then minus, now let us put 1. So when I put 1 here, this will be 2 minus 1, then you get a 1. So that means altogether here I'm getting negative a half. Then again, put 1 in here. We are going to have a 3 here. Then divide by 1 here. So that will be a 3. So plus a half, then the natural log of 3. And then put 1 here. We shall get a 3 here. Then times 2. That is a 6. So we get negative 1 out of 6. Now when we open the brackets, you will get negative 1 out of 6. Now I'm putting these constants here without the natural log separated from the natural logarithms, okay? Now when I open the brackets, this one is going to be a plus. So plus a half. And then this one again affects this. It will also be plus 1 over 6, okay? And of course, this is negative, this is positive, so that one disappears. Then here, we are having plus a half, then the natural log of 5 over 3. Then this is a minus, so here we shall get minus a half, then the natural log of 3. Now here, of course, the LCM of 10 and 2 is going to be 10. Now 10 divided by 10, you get what? 1, then times this one. So you get negative 1, then plus 10 divided by 2, 5 times 1, that will be 5 there. Okay? Then plus a half is common. I can factorize it. Then we have natural log of 3 here. 5 over 3, then minus the natural log of 3. You see that? Now when logarithms to the same base are subtracted, what do we do to the powers? We divide them, not so? So here 5 minus 1, that one will be a 4 out of 10, then plus a half, the natural log of, this will be 5 over 3, divide by 3. And 5 over 3 divided by 3 is the same as 5 over 3, then times the reciprocal of this one here, that will be 1 over 3. Now you are getting 5 over 9, okay? So, getting 5 over 9 here, and of course this one simplified, by 2 you get 2, then by 2 you get 5. So this will be 2 out of 5, then plus a half, then the natural log of 5 over 9. Isn't this what they told us to show? Let's check and see. Exactly, 2 out of 5, then plus a half, natural log of 5 over 9. Question 8 is coming from vectors relative to the origin O. The points A, B, and D have position vectors given by these. A fourth point C is such that A, B, C, D is a parallelogram. Then part A, find a position vector of C and verify that the parallelogram is not a rhombus. I'm going to do a simple illustration here, like this, for the parallelogram. Now, a parallelogram has two pairs of parallel sides. So maybe that is the one there. Then we have that. like that, and also like that. So maybe this is A, then B, then C, then D. Now for the parallelogram, this one here, AD, is parallel to this, and they are equal in length. Okay? Then DC is also equal to AB, and they are also equal in length. Now, for me to go to from A to C, that is AB, then plus BC. So I can say AC is equal to AB, then plus BC. Okay? Also, we can use this one. AB is equal to DC. You can use whichever you want. So in vectors, of course, I can get the last minus the first. If you have been following me, now you know this, that AB is the same as OB minus OA. Then this one will be equal to this OC, DC here will be OC minus OD. What are we looking for? OC. That means bring this on this side. So we have OD, then plus OB minus OA will give us OC. Are we given these ones here? Yes. So OD is 3, then 0 and 2, because we are not seeing a J in there. Then OB is 2, 5, 3. Then OA, we are seeing 1, 2, 1. Then we get our OC here. So our OC is therefore going to be 2 plus 3, that is 5 minus 1, that will be a 4. Then 0 plus 5, that is a 5 minus 2, we are getting a 3. And then 2 plus 3, that is 5 minus 1, that one gives us a 4. Now, since these ones are given in I, J, and K, in terms of I, J, and K, I will say OC is equal to 4I plus 3J, then plus 4K. And that is that. But they say that we verify that this is a parallelogram, not a rhombus. So a rhombus has gotten all sides equal, and also two pairs of parallel sides. Now, we need to get DC. We also get AB. Are they the same? Then BC. No. DC and AB, are they the same? Then BC and AD, are they the same? So that is now what we are going to do here. Let's begin. AD. Like I said, that is OD minus OA. Are we there? So this one is going to be our OD is 302. Then minus our OA is 1. It's right here. 1, 2, 1. Then this one will give us 2, negative 2, 1. Okay? That is our AD. So what is the length or the modulus of this one? This one is going to be 2 squared, then plus minus 2 squared, then plus 1 squared. This is 4 plus 4, 8 plus 1, 9. Root of 9, that is a 3. Then we go to BC. Okay? AD, then let us look at BC. Are they the same? This one is going to be OC minus OB. OC, right from here, we got this 4, 3, 4. Then minus OB is 2, 5, 3. Right from here. Then when we subtract these two, we are getting a 2 here, a negative 2 here, and a 1. Do you see that it is the same? Then we just conclude here that BC, the modulus, this one is also equal to what? To 3 units. Then, because now if this one was a rhombus, then that means all lengths are going to be equal. Okay, now let's go to the other pair, that is AB. So which is OB minus OA. Now OB is 253, and then OA is 121. When we subtract these ones, we get 132. So what is therefore the modulus of AB? This one is going to be the square root of, we are having 1 squared, then plus 3 squared, then plus 4 squared. Is it 4 or 2? 2 squared. And then what do we get here? This is 9 plus 1, 10, then plus 4. That is root of 14. Then what else? AB in correspondence with DC. So what is DC? DC is OC minus OD. Now our OC, we got it as 434. Then our OD is 302. Then here we are getting 4 minus 3, you get a 1. 3 minus 0, you get a 3. 4 minus 2, you get a 2. Do you see that it is also the same? And these vectors are different from these ones. Okay, so we conclude, and then we say that DC here is equal to also root over 14. So this is a rhombus. I mean, this is a parallelogram. So I can conclude, and then I say, since the adjacent sides, the adjacent sides are not equal, since the adjacent sides are not equal. So what am I talking about? The adjacent sides. This one is not equal to that. Okay, since the adjacent sides are not equal in length, and there are 2 pairs of parallel sides, okay, that are not equal in length, A, B, C, D is a parallelogram. So for the rhombus, all lengths must be what? Equal. But find the angle BAD, giving your answer in degrees. Now I add something like this in my sketch. Now when I check back here, based on what I'm having here, they are saying BAD. So me, I just drew like this, but I don't know whether it is like that. It was just a sketch, okay? So suppose we have this as our B. Maybe this line was supposed to be like that, such that the angle is obtuse, or like that, whatever, okay? So I just used this one as an example. Now we have a D here, we have an A here, we have a B. When we are finding the angles, okay, the angles in between the 2 vectors, we either close in or we open. What do I mean? Closing in, you say BA, then DA. Or you open, you say, you move away from the angle. So that is AD and then AB. Now, I think we have these vectors AD right from here. We have the AD. AD is here. 2, -2, 1. We have 2, -2, 1. Then we also have AB. AB is, We also got it. It is here. So it is 1, 3, 2. 1, 3, 2. Like that. Okay. Now we use the scalar product because when we are finding the angle between the two vectors, we use the scalar product. So using the scalar product, I'll get AD, then I dot it with AB. Okay. Then this one will be equal to the modulus of AD, then times the modulus of AB, then cosine of the angle in between them. When we dot these two, we have 2, negative 2, 1, dotted with 1, 3, and 2. Then this one will give us, did we get the lengths of AD and AB? I think so. So AD, the length is 3, and then AB, this is root of 14. So we shall have 3, then times root of 14, then cosine of theta. So when we multiply here, we get a 2, then in the middle, we get negative 6, and then here we get a 2. So this one will be 3, then the square root of 14, the cosine of theta. Then 2 plus 2, that one gives us a 4, then minus 6, that is negative 2. So meaning negative 2 out of 3. So the fact that this one is a negative and cosine is negative in the in the second quadrant, that means the angle we are going to get here is obtuse. So negative 2 out of 3, then the square root of 14. So what do we get here? Our answer is in degrees. So your calculator has to be in degrees, and then we give the answer to 1 decimal place. Arc cos of negative 2 out of 3 root of 14. And then this one gives us 100.3. 100.3. The answer is in degrees, so please indicate the degrees. If you don't indicate it, we shall assume that that angle is in radians. Then next, part C, they are saying that find the area of the parallelogram correct to 3 significant figures. Now, we are having our parallelogram here, okay? Like I drew it before. So we have something like this here, and then I'm going to connect this to that, and also this to that. Well, this is B, this is A. Don't mind about the diagram. This one does not depict that the angle that we are having is 100, but I'm just going to leave it that way, 100.3 degrees, okay? Of course, these two angles are equal, the opposite angles. So even this one is going to be 100.3 degrees, okay? So that means I'm going to find the area of one side, then area of one triangle, then I multiply it by 2, because we are seeing two congruent what? Triangles. Our AD, we got it as 3. So this is 3, then this is root of what? 14, okay? It looks weird. Like this AB is bigger than this, but it is just a sketch. No mark for the sketch, okay? Now, area of the parallelogram ABCD will be equal to 2 times the area of a triangle, let's say ABD. So this will be 2, then times a half. Area of a triangle which is not right angled, you just need to know two sides, this, and then the angle in between. So it will be a half times A times B, then sine of theta, okay? This one here, then times, this will be 3, okay? Then 3, then root of 14, and then sine of this 100.3 degrees, okay? And if you want, actually I'm going to use the exact value here. I'm going to write maybe 0.26 because it was 26 and the rest of those figures there, okay? Or if you want, since cosine of theta is this, sine of theta is going to be root of 1 minus cos squared theta, okay? Then you get the exact value. So suppose they had told us to find the exact area, then we would do it that way. But here, you just put this one in your calculator and you go, okay? So what do we get here? Now, the answer that I got here, I'm going to leave it there. And then I just say, of course, 2 times a half, that one goes. So we have 3 root of 14. Then from there, we say sine of the answer we got. And then to 3 significant figures, we shall get 11.0. 11.0 square units. So don't put centimeters squared. They didn't tell you that the dimensions were in centimeters. Question 9 is coming from complex numbers, but the complex numbers u and w are such that u minus w is equal to 2i and uw is equal to 6. Find u and w, giving your answers in the form x plus iy, where x and y are real and exact. Now, the moment they put exact, that means there is a possibility of maybe getting a quadratic equation, and then also what you get from there is not a factorizable one, so you get SADs, okay? Now, from here, what we can do, we are supposed to solve these two simultaneously. I can express u in terms of w in the first one here. So we shall have w, then plus 2i. Then I substitute this in the second one here. So where there is u, I'm going to put 2 plus, w plus 2i, then times there is a w here. Then this one is equal to 6. When I open the brackets, we shall have w squared, okay? Then plus 2wi. Then I can bring this one this side. It's a minus 6, then is equal to 0. So this is a quadratic what? Equation. So I'm going to solve it using the quadratic formula. I can even write this one better like this, 2i, then w minus 6 is equal to 0, such that we can easily see that it is a quadratic in w. So using the quadratic formula, w is going to be minus b. The b is going to be this 2i, then plus or minus to the root of b squared minus 4, then a, and then c, okay? Then divide by 2a. And in complex numbers, you should know that I squared is always equal to negative 1. Now, what do we get here? We shall get negative 2i, then plus or minus. This one will give us 4i squared, which is going to be a negative 4. Okay, and then this is a positive 24. Then 2. That means here we are going to have root of 20. And root of 20 is the same as root of 4 times root of 5. Meaning we get 2 root what? 5. That means I will get negative 2i, then plus or minus 2 root of 5 out of 2. And then this one will give us 2 will simplify these ones to negative I, then plus or minus root of 5. Now from here, we are going to have the first answer for W. Remember, when we are writing complex numbers, we write the real first, then followed by the imaginary. So this is going to be the real part because it doesn't have the I. The part with the I is the one which is imaginary. So taking the positive root of 5, then here we have minus I. This will be the first answer for W. Then the next answer for W is going to be, now we take the minus here. So it is negative root of 5, then minus I. Remember, this one is a minus I there. Then what will be our U? We are substituting here. You remember here? Okay, so we shall have W, which is root of 5 minus I, then plus this 2I here. That means U is going to be root of 5, then plus I. Not so? That is that. Then when you come to this one here, we shall have negative root of 5 minus I, then plus 2I. So that means the answer here for you is going to be negative root of 5, then plus I. That is that. Part B. On a sketch of an Gann diagram, shade the region whose points represent complex numbers Z, satisfying the inequalities. I've already said that if you see modular signs on one side of the inequality or equation, then that is a circle, and I can prove it. Suppose Z is x plus iy. Then we have this minus 2i. Okay, then less than or equal to 2. Then separate the real from the imaginary. So we have the real part is this. The imaginary is y minus 2 here, like that. And then how do we get the complex? The modulus of a complex number. That is the square root of the real part squared, then plus y minus 2, then squared. That's the imaginary part. Then less than or equal to 2. In fact, I can write maybe this one with the equals. So suppose I remove this because an inequality is just talking about the region. Okay. Now when we square both sides, that means we are going to get x minus 2 squared, then plus y minus 2 squared. This is equal to 2 squared. Comparing with the general equation of the circle you studied in Pure Mathematics 1, this is x minus a bracket squared, then plus y minus b brackets squared. This one is going to be equal to r squared. So this one has a center AB. Now, these two look identical. That means the center for this one is going to be 2, 2. Then the radius is also 2, which is here. You see? So when you see the modular signs on one side of the inequality or equation, then you should know that that is a circle. So the first thing you do is to create a negative here, so that you get the center of that circle. But then when you create the negative in between these two, you shouldn't change the meaning. So I will put the 2 here, then plus the 2i. Okay? So when we open the brackets, we come back to this. You see that? So this is a circle of radius, 2, and center 2, 2, like that. Okay, that is the first one. Then the next one, here we are drawing a half line. So for 0 less than or equal to the argument of z, then less than or equal to pi over 4, we draw a half line. This is a half line, from the origin, starting at the origin. A half line starts at a certain point, but other lines just continue. Okay, so starting at the origin is 0, 0. Okay, at an angle of 45 degrees, which is pi over 4, at an angle of this from the positive real axis. I'm going to show you that. Then of course for this one, when we remove the less than or equal, we shall have real of z, which is equal to 3, and that will be a vertical line. So, and it will be bold because of the less than or equal. So or equal means that all the points that are on that line will be considered. Okay, then what else do we have? For this one here, the circle, since they are saying less than or equal to 2, when we draw that circle, the circumference is going to be bold. Why is it bold? Because any point that is on the circumference of the circle is 2 units. That is the radius, 2 units from the center. So it is needed because they said O equal. Now, we can take the equal and then the less than, that is for the points that are inside the circle. So any point that is inside the circle, its distance from the center is less than the radius. Okay, so we are considering all points inside the circle and also on the circumference. But suppose we were given less than 2, that means we are only considering the points that are inside the circle. We therefore do not make this circumference bold. It has to be dotted because no point on the circumference for that case will be needed. Is that clear? Okay, then I have already said that when you are sketching, always use the pairs of compasses and then the ruler, your pencil, such that you plot something that is very accurate. Okay, so what we are going to do is to draw the axis here. So I will draw, this is my imaginary axis, and then this is my real axis. Then after drawing them, I'm going to use the ruler here such that I can do the markings here. So this one will help me when I'm drawing the circle such that I draw a perfect one. Okay, so you mark these points very well. So when you are stretching your compass, the circle will be passing through the required points. Okay, then I also turn it around and I do the same. So I'll put it here and then I do the same here. Now, of course, I'll make it pass through this, coincide with that line there. Then we have this point here marked, this one here, this one here, this one, this one, this one, maybe one down or two, like that. Then I can take that away. Label your axis. This is the imaginary axis of Z. This is the real of Z. Are we there? So like that. Then label them. This is 1, this is 2, 3, 4, 5, 6. This is -1, -2, -1, -2, 0. It's -3. This is 1, 2, 3, 4, 5, and then 6. Then from there, we plot our center. Our center is 2, 2. Now, 2, 2, I will bring my ruler here. I put it on this 2 here. Then I move 2 units, 1, 2. Okay, so it will be here. So plotting that point is very, very important. So there is a mark given for it. Okay, now from here, you need to move 2 units this way, move 2 units this way, move 2 units this way, move 2 units this way. So that means when you are drawing, it should touch this axis here, also touches this one, then it will touch a tangent there and also a tangent there. Okay, but if you don't use a compass, you will draw something that is close to a potato rather than a circle. So that's why I recommend the use of a compass. So bring your your compass pointer, put it there, and then you stretch to 2 centimeters. But mine cannot reach 2 centimeters. Okay, so what I'm going to do is to put it at 4 centimeters and then I will diminish it. Okay, so I will draw that circle there, but then I need to draw these tangents to guide me. Okay, so I can move, so this one here, then we move 2 units. So 1, 2, of course, this will be the real axis. Then also up here, 1 and then 2. So we have that. Then the vertical ones, we have this one here. So we move 1, 2, it is here. Then also this way, 1, 2, it should pass through here. Now, when I'm diminishing this one here, I should make sure that it touches these circles here. The circle shouldn't protrude like the way you are seeing it there. Okay, the moment we see this one here in your work, we just cross without asking anybody. Okay, so now if I diminish again a little again, but for you, when you put it on the I mean, when you stretch it on your you stretch your compass on the ruler, it is very fine. You just draw once. Now you can see that my circle is touching here, touching here, touching here, and here. But then we don't need these tangents here, so take them off. We don't need this. We don't need that. So that will be the one there. Okay. Then we need to draw a half line. Okay, we need to draw this line. Real of z is equal to 3. This one is going to be passing through. So I'll just get this, then I duplicate it. It has to be passing through this one here. So this is the one here. Okay. Now, after that, actually label this one and you put, this one is called real of z, which is equal to 3. But the wanted region is this one. Okay, not this way. So it is just a boundary line. Okay, if you can check what is here, it is less than or equal. So we need the less than part. Then next we need to draw a half line. So you get your protractor, you put it here. You see the essence of using your instruments. They can give you a perfect diagram. Now, when I put this one here, we shall measure 45. So I'll draw through 45 is there. And so, just like that. Then, after that, you can take off your protractor. So, this angle here is pi over 4. You see that? Now, we are considering all of these points in this region here. So, any point that is in here, its angle from this positive real axis is going to be less than the 45 degrees. You see that? And then any angle that is on this line is exactly 45 degrees from the positive real axis. So that's why we are considering here. But again, we are supposed to look at the left of this line. So this is the region, okay, and it has to be inside the circle. So we have to shade here, okay. You shade this well, so let me shade it. So like that. Now the moment you draw and then this line of yours here passes through the origin like that, it's no longer a half line. In other words, it is starting from another point, not the origin. So it doesn't exceed here. Okay, that is very important. So that is our diagram there. Question 10 is coming from word problems in differential equations. A tank containing water is in the form of a hemisphere. The axis is vertical. The lowest point is A and the radius is R, as shown in the diagram. The depth of water at time t is h. At time t is equal to 0, the tank is full and the depth of the water is r. At this instant, a tap at A is opened and water begins to flow out at a rate proportional to root of h. The tank becomes empty at time t is equal to 14. The volume of the water in the tank is V when the depth is h. It is given that V is equal to 1/3 pi into 3rh squared minus h cubed. Then part A, show that h and t satisfy a differential equation of the form, this one here, where B is a positive constant. Okay, now since water is flowing out, okay, that means the rate of change of the volume is a negative. Okay, it's minus this one here. So dv, okay, dv, in fact they said that water begins to flow out at a rate proportional. So we shall say that dv dt is proportional to to root of h, okay? Or maybe better I can say to negative root of h, because water is flowing out, the volume is reducing. Are we there? So the rate of change of the volume has to be a negative. Now we remove the proportionality sign and then we put a proportionality constant. So that means our dv dt then shall be equal to negative k root of h. Are we there? Then from there, we are also given v, which is equal to, we have something here. So if I maybe multiply out everything, we are going to get the 3 here will cancel with that 3, and then we get pi r h squared, okay? Then minus, we shall have a third pi, then h cubed. Now we need to get dv dh, because as the depth of the water changes, even the volume of the water in here is also changing. So we need to get dv dh. So dv dh will be equal to 2 pi rh, okay? You drop the power and then you reduce it by 1. Then we differentiate this one here. When the 3 comes here, it will multiply with a third, and then that one disappears. Then we have pi h squared. Are we there? Now here, we are finding the h dt. So using the chain rule, dh dt shall be equal to dh dv, then times dv dt, not so? But then dh dv is going to be 1 over dv dh. Are we there? So our dh dt shall be equal to, we have, what do we have here? dv dt is here. Okay, so we have dv dt, or maybe the reciprocal of this one is going to be 1 out of 2 pi rh, then minus pi h squared, then times, this is negative k, then maybe h power half. I can write it like that, you see? Then I can simplify this one here. We can simplify it how? I can take the h down, okay? So when I take the h down, because even here you see it down, so we are going to have negative k, then out of, I'm going to have h down. Now since the power is a positive, when it comes down it is going to be a negative. Are we there? Then 2 pi rh minus pi h squared. Then we continue. Now we multiply h all through. So we are going to have 2 pi r, then you have here h power negative a half, then times h power 1, then minus, this is pi, then you have h squared, then times h power negative what? A half. Now here, this is 2 minus a half, you are going to get 3 over 2. So we shall get negative k out of 1 minus a half, you get a half. Because here we are using rules of indices, not so? So we shall have 2 pi r, then h power half. Then here minus pi, then h power 3 over 2. Have we gotten the denominator? Yes. That is the h dt. Now, they are talking about that b there. But now you can see that in here there is no pi. So meaning I can have this one like this, that we are having negative k out of, pull out the pi, okay? Pull out the pi, then you have 2r h power half minus h power 3 over 2, and therefore dh dt is going to be negative b out of 2r, then h power half minus h power 3 over 2. Then someone will ask, where has this one gone? B shall be equal to that negative k out of what? Pi. So I get this, the k. Actually, it is the k over pi because the negative is still there, okay? So here, I will say b is equal to k over pi, okay? And that is that. Part B, solve the differential equation and obtain an expression for t in terms of h and r. Now, we have our, if we can go back, this is our, this one here is our differential equation. So dh dt is equal to negative b out of 2r, then h power a half minus h power 3 over 2. Was it that? Yes. Then we have that. So we separate variables. You know, when we are solving the differential equations here, we separate the variables. So separating variables. And then after that, we integrate and integrating. Now, this one has 8 marks. That means we have some good job to do. Okay? Now, how are we going to do this? So when we separate variables, of course, you just cross multiply. So you will get this 2r, then h power half minus h power 3 over 2, like that. Then dh. Then this one will be equal to negative b, then dt. Now, we integrate both sides. Okay? When we integrate, of course, you increase the power by 1 and then you divide by the new power. So you will get 2r, then h power 3 over 2 when you increase this by 1 out of 3 over 2. Then minus h, you increase the power by 1, that one becomes 5 over 2. Then out of 5 over 2. Then this one will be negative b t. Then I can put a constant c. Okay? Now, what else do we have? Of course, this one will somersault. The 2 will multiply with the 2. You will get a 4. Then out of 3, r, then h to the power of 3 over 2. Minus, this will be 2 over 5. Then h power 5 over 2, which will be equal to negative b of t, then plus c. So what we are having here is the general solution of the quadratic, of the differential equation. Now, we are given units, conditions. So when we use those conditions and then we get the value of c, that means we would have gotten the what we call the particular solution. So let's go and we check. When we go back here, they said that the tank becomes empty at t is equal to 14. Okay? At t is equal to 14. Now, that means h will be 0. So if the tank is empty, okay, that means there is no depth of water in there. So h will be 0. So I will say at t is equal to 14. Then h is going to be equal to what? 0. Now, when you put h being 0, so this way you are getting 0, then here you are getting negative 14, then b, then plus c. What does this imply? That c is equal to what? 14b. Not so? So meaning that I can pick this one here, and then from here I can write what we call our, this one is called what? Our particular solution. So plus 14b. Okay? Now, there is also something they said here, that the depth of the water at time t is h. At t is equal to 0, the tank is full and the depth of the water is r. So you see that at t is equal to 0, at t is equal to 0, h is equal to r. You see? Now we can substitute here. We can have 4 out of 3, then there is r, then times our h is now equal to r, not so? So then 3 over 2 minus 2 out of 5, then r here, power 5 out of 2, then this one will be equal to t0, then plus the 14b. This is a 1 here, so add it on the 3 over 2, you're going to get the 2.5, which is the same as this. So meaning I'll get 4 over 3, then r power 5 over 2, minus this is 2 over 5, then r power 5 over 2. This one will be equal to 14b. So I can write b because it is a constant in terms of r. Remember here they said we get the expression of t in terms of h and r. So we need to eliminate this b here, okay? Now, what do we have here? We can simplify this. So 4 times, this 5 times 4, you get 20. Then 3 times 2, you get 6. Then out of 3 times the 5, you are going to get 15. So this one is 20 minus 6, that is 14 over 15, okay? So we shall get 14 out of 15 of r power 5 over 2. This one will be equal to 14b. Now that means b is going to be equal to, when you divide all through by 14, this 14 will go. So b will be 1 out of 15 of r power 5 over 2. You see that? Now we go back to our particular solution here, and we say, I will bring this one down here. Then 14b, we have seen that it is what? It is this, not so? So let me just put it here and we say plus. This is 14 out of 15 r power 5 over 2. You see that? Then we need to simplify this one here. We make t the subject of the formula. Is that correct? Okay. Now, even here, where there is b, I'm going to put this value. Are we there? So I'm going to say, let me do this. Let me try to put this one a little bit down. Then I extend this one a little bit. And then here, where there is b, I'm putting this. So it will be negative 1 out of 15. Then r power 5 over 2. And then what else? I think there has to be a t because it was b, negative bt. Now you make this t the subject of the formula. So I'm going to bring this side, okay? Then we can have, or let me first multiply all through by 15 such that I eliminate the denominators. Are we there? So this 3 will go into the 15 5 times. 5 times 4, you get 20. So we shall get 20, then r h power 3 over 2. Then this 5 will go into 15 how many times? 3. Then times 2, you get 6. So minus 6, then h power 5 over 2. And then what else? 15, of course, these ones will go. So we shall have negative r power 5 over 2 of t, then plus 14 r power 5 over 2. Now bring this on this side. We are making t the subject of the formula. So we have r power 5 over 2 of t. Then this one will be equal to 14 r power 5 over 2. Then when this one crosses, it becomes a plus. So plus 6 h power 5 over 2. Then when this one crosses, it will be a minus. Then 20 r of h power 3 over 2. Are we there? Then after that, we are going to continue, and then we say that we divide all through. I think you divide all through by this one, so t will be equal to, what do you get here? Don't you think this is 20? I think this one here is 20. No, it is not the same. Pardon me here. It is not the same. So we are going to have 14 r power 5 over 2. Then we divide by r power 5 over 2. Then plus 6 h power 5 over 2. Then we also divide by r power 5 over 2. Then minus, this is 20 r, then h power 3 over 2, then out of r power 5 over 2. Okay, now you can easily see that this one is going to disappear. So our t is going to be 14. Now, in indices, we have a rule that if you have a power b out of c power b, then this is the same as saying a over c, then power what? B. So this h here has this same power as the r down. That means I can have the 6, leave it out there, then I will have h out of r, then these two have this power. Okay, then how about here? Let me first simplify this one here, minus 20 r, and then this one. So we are having r. I can take this one down, and then we have something like 20, then h power 3 over 2, then divide by, this will be r power negative 1, then times r power 5 over 2. Now t here will be equal to, in fact, let me not waste time. I'm just going to pick the whole of this, duplicate it, then put it down here. We have something like that. Then what are we going to have here? So this is 2.5 minus 1. Don't you get 2.5 minus 1? You get 1.5. So that means here we are going to have okay, let me just skip this one here. We are going to have our r here. We'll be having a power of what? 3 over 2. 3 over 2. Now, just like what we had here, I'm also going to put these ones together. Not so? So meaning my answer here is going to be this minus 20. Then I say h out of r, then to the power of 3 over 2. And that is that.